Welcome to all the learners, my greetings and namaste. This session is from the course of Certificate in Information Technology 002, first block, first unit, Attributes of Information Technology. And in this session, we are going to talk of information storage. In case you are wondering what is meant by storing information, by information storage we mean devices that can store information or data for a long period. Let us be very clear here that we are not talking of the memory used for internal working. Primary storage is that kind of storage. It is used for internal working of the computer when the computer is on. It is used for the random access memory or RAM of the computer. It has a fast response time, typically something between 10 to 100 nanoseconds. But as we know, when the computer is switched off, all this information is lost. So, primary storage is that which is directly used by the computer while computing, and it is very fast, it is more expensive, and it is used only when the computer is on. In this session, we are going to take a more detailed look at what we call secondary storage. Secondary storage is that which is used for storing information on a long-term basis, and this is information that will stay with us for months, years, or maybe more. Such storage typically has a response time which is slower than that of the main or memory or primary storage of a computer, but it is much cheaper. There are many different types of secondary storage devices in use, and these are not used directly by the computer while it is doing computations. So, the difference therefore is that it is not like RAM or it is not the scratch area of the computer, it is where we store information for a longer period. So, let us look at these sources of information. These storage devices. One of the most common devices that is used for secondary storage, as we know, is the hard disk drive. Hard disks or hard drives or hard disk drives, as they are called, store data on electromagnetically charged platters. So, there is a series of platters, each of which stores some information, and as you stack them one on top of the other, you are able to store quite a lot of data. Modern hard disks used for personal computers today can store something like 2 terabytes or more of data. For server class machines, this can go up to 12 terabytes and more. But normally in our own personal computers or laptops, we use hard disks that can store roughly 2 terabytes or so. Over the years, the cost of these devices has been coming down significantly. They cost much less than primary storage or primary memory. They are meant for long-term storage, as we know, as we have just seen. And apart from being used as actively as part of the computer setup itself, we also use external hard disks to take backups of data and store them in a safe place, just in case something happens to the main computer. Because of the slower speed of hard disks or hard drives, if you have the operating system program on a hard disk, the booting up the computer, then shutting it down can be a slow process and can take a minute or two, which can sometimes tax one's patience also. So, what can one do about this? A few years ago, solid state drives started to become more and more popular. They have a fair amount of capacity, they can store perhaps a terabyte of data and even more, but the cost factor is what prevents much more widespread adoption of these drives. So, their storage capacity, economical storage capacity is less than that of hard disks. However, they cost much less than primary memory would. They are also meant for long-term storage, just like hard disk drives. And how do they differ from a hard disk then? The key difference is that a solid state drive is a totally electronic device. The data is stored entirely in electronic flash memory. There are no mechanical moving parts as you have in the case of a hard disk, and they are fast because they are fully electronic. The response time is very good. So, what we often do these days is we take the best of both worlds. We store the system programs and operating system on the solid state drive, which may be say a 256 gigabyte or a 512 gigabyte drive, which is sufficient for storing our OS. And then you will find that the computer boots up in seconds, maybe in 5 or 10 seconds, and correspondingly the shutdown is also very fast. So, that makes it a pleasure to turn on the computer. And as far as the real actual storage of our bulk data goes, we continue to use a conventional hard disk, electromechanical hard disk for storage of the data. So, this way we are able to utilize the high speed of a solid state drive and the low cost and large storage capacity of a hard disk drive. Let us take a look now at a hard disk and a solid state drive and see the differences between them. So, to recapitulate, hard disks are cheaper, solid state drives are still more expensive, although costs have been coming down over time, but they are still more expensive than hard disks. When it comes to speed, a typical 7200 RPM hard disk can transfer something like 150 megabytes per second. On the other hand, an SSD or solid state drive with a SATA 3 connection, SATA stands for the interface between the drive and the computer. It is the serial advanced technology attachment. It can transfer at a maximum of 600 megabytes per second. So, if you are using a solid state drive with a SATA 3 connection, you are still limited to 600 megabytes per second of data transfer rate. However, PCIe connections are now becoming more popular and affordable. With this, you can transfer at rates of something like 1.2 gigabytes per second and maybe even more. That makes it really fast to store data and retrieve data from the solid state drive. However, a hard disk gets confined to 150 megabytes per second, which means that a solid state drive with a PCIe interface can be almost 10 times faster than a hard disk. Since a solid state drive has no moving parts, no mechanical moving parts, so it is more robust and more reliable. Although hard disk drives are still quite reliable, it is not as if you have to worry too much. However, since you have mechanical moving parts, the possibility of their failure is higher. Hard disk drives use more power than an SSD because there is mechanical movement that the electronics has to drive. Solid state drives use less power, and an affordable capacity for a solid state drive would be say 256 or maybe 512 GB. Beyond that, they would start to become too expensive. So, then depending on the kind of budget you have and the kind of application you want to put it to, one can make a choice between using a solid state drive, a hard disk drive, or a mixture of the two. Next, let us look at optical disk drives, which have been very popular in the past. Their popularity is decreasing these days, but they are still by no means obsolete. A CD or a compact disc read only, a compact disc read write, a digital video disc are all optical discs. They have much larger capacity than most hard disks. They are not affected by electromagnetic fields, unlike hard disks. A hard disk can get damaged if it is subjected to a strong magnetic field, but optical discs store data in a different way, and hence they are not affected by magnetic fields. DVDs or digital video discs have larger capacity than compact discs, and data is recorded on them by stamping them with very small microscopic dots called pits and lands. Lands are portions which are flat and reflect light. Pits are hollows and they scatter light. So, when a laser beam is shown onto the tracks in the disc, it generates different electrical signals when it hits pits and lands, and this way you are able to encode the information on the disc with zeros and ones. There are different types or kinds of optical disc drives. There are those which can be written to only once. These are the so-called worm discs, write once, read many times. So, a recordable CD or a DVD of recordable can be written to only once. A recordable CDR has a capacity of about 650 MB. One cannot delete the data on them, and it is often used for audio recording. A CD read-write or rewritable CD can be written to many times, say something like 1000 times. They come in different speeds which are given as 1x, 2x and so on. Typically, speeds today would exceed 32x or even go up to 52x. The faster the speed, naturally, the faster data can be written to or read from them. Read only CDs go up to 52x, read write CDs perhaps would stop at 32x. Digital video discs or DVDRs have capacities of about 4.7 gigabytes. They can be written to only once, and you also have read write versions of these that can be written to say 1000 times and have a similar capacity. So, we have in optical discs CDR, CD rewritable, DVD-R and DVD rewritable. A very popular method of storing information these days is pen drives. In fact, I don't have a pen drive right now with me, but they are often used to transfer data from one computer to another. When you don't have a network available readily, conveniently, or when you don't want to use it. Pen drives, like solid state drives, use electronic flash memory to store data, and they have different storage capacities going up to say 32 gigabytes. And the good part about them is, or the fun part about them is that they come in many different creative external shapes. So, they have very cute and interesting to look at shapes, although of course, inside everything is the same. So, you also have flash drives that store data in flash memory like a pen drive or a solid state drive and can be placed inside. So, flash drive is a more general purpose term than pen drive, but all pen drives are definitely flash drives. There was also a device called a floppy disk, which is virtually obsolete now. They were very slow, they had very limited capacity, and the earliest versions of floppy disks had a capacity of just about 126 kilobytes, a capacity at which most of us would be laughing today. Later, 1.2 megabyte floppies became available and popular. The problem with floppy drives, apart from their speed, was their bulk. They were very large. The drives that were required to read them were big, and their reliability of data storage was not very good. All too often, one found that you had recorded data on a floppy drive, but when we were trying to read it back, you got an error and there was no way of retrieving that data. But before the advent of hard disks, floppy drives were the way to store data, and they were also used for backups. If you are wondering how one would use 126 kilobyte floppy drives to store data, to backup data, we have to also remember that in those days, the hard disks had also very limited capacity. So, in a few floppy disks, you could store all the data on your computer. Now, what is the purpose to which these storage devices are put or can be put? One very common use is to transfer data. So, for example, you can buy an audio CD or you can buy a movie that is recorded on a digital video disc. You can of course also copy your computer data and take a backup on those. Backups are a copy of your active data on the computer. So, you may want to restore that data at any time that your computer gives you a problem. So, that is what a backup is for. The characteristic of backups is that since the data on your active computer is changing, your computer is in active use, you are reading, writing, deleting, adding, making a lot of changes to your data. So, that data can change quite a lot. You would therefore need to be backing up your data quite frequently to ensure that you have the latest changes for any needed restoration. So, depending on how frequently your data changes and how important it is to have the latest data with you, you may take backups every week or every fortnight or every month or so. If it is more important, you would take it every day. And normally, one would store 3 generations of backups, which was the normal scheme of having the backup, the father and the grandfather. Now, backup data therefore is something that you would expect to use if you had a problem with your computer. But there is another kind of storage, archival storage. Archival data is data that is not in active use. This is data that you might want to store for a long time to come, 10, 20 or 50 years or even more. For example, consider a film library. All films that have been produced, you would want them to live on. So, a film that was made in say the 40s or 30s, can we still see it today? That depends on whether it has been stored properly and whether it is available in the archives. When you want to store data for such a long time, the reliability of that storage medium becomes very, very important, because you may not have it available on your active computer storage later. When you come to backups, you would expect to store backups for a small period of time, because after not so much time, you will find that your backup data has changed. But archival data is not going to change. If you are storing a film that was made 100 years ago, it needs to remain stored. That film is not going to change. So, what are the storage mediums that we can use for this? Hard disks are good for 10 to 15 years if you use them once a year or so, just to make sure that things keep working. So, it is always a good idea to use the archival medium and exercise it once or twice a year. Flash drives have not been around all that long, but certainly they should be able to last 10 to 15 years. But what do you do after that? The best way to store data for a very long time is perhaps to use tape drives, because tape drives can store very large archives of hundreds of terabytes or more. Hard disks and flash drives and all are fine if you want to store a few terabytes of data. But when you have hundreds of terabytes, petabytes of data, you would need a huge tape library. And that is what is typically used for archives. Again, depending on the kind of application, these tapes could be stored in banks that could be accessed by perhaps a robotic arms, and if you wanted to retrieve a particular tape, the robotic arm would know which part of the library had that tape. It could retrieve that tape, load it onto the drive so that you could read that data, and then once you are done, the robotic arm could store or replace the tape in the correct place. Not all archives have to be unmanned or robotic. It is quite possible to have archives where physical retrieval of tapes is needed and done by a human being. What are the precautions that you would need to take for archival? Again, in backups, things are fine, because you would be exercising the backup now and then. And if nothing else, you would be replacing the backup with a more recent backup all the time. But what about archives? First of all, archival material should be stored in a climate controlled environment to minimize the chance of anything happening to the storage medium. humidity, heat and other dust and other atmospheric conditions, ambient conditions can spoil what is available on your storage medium. Every few months, the device should be used so that it just does not decay away. And one very important thing that one must not forget is that the drives and other interfaces may become obsolete and hard to obtain over time. If today you have something that was stored on floppy drives, you will have a difficult time accessing the floppy drive or finding a floppy drive on which to read your data. And even if you have a computer and even if you have the floppy drive, you may not be able to attach it to your computer because the interfaces have changed. So, one needs to keep an eye on the kind of advances that are happening and periodically transfer your archival material to better or more modern devices every few years. Today we have hard disk drives, we have tapes, we have solid state drives. One doesn't know what kind of storage device will come tomorrow. So, material that we have on this can be transferred to those devices as and when they become available. So that 100 years later or 200 years later, if someone wants to see a film made in the 1940s, they are able to do it. Tape drives, which are used for archival, are really sequential. So, access time can be quite slow because it can take quite a lot of time to reach the place where your material is stored. But once you reach that point, they are not much slower than hard drives in actual reading or data transfer. So, in this session, we have seen different types of storage. We have understood what storage means, how primary storage and secondary storage are different. Primary storage being the active working area of the computer, and secondary storage is long-term storage. We've learnt about different kinds of storage devices, secondary storage devices such as hard disks, solid state drives, pen drives, optical drives, CDR, CDRW, DVD-R, DVD-RW, and tape drives, which are used for long-term archival. I hope this was very interesting. We do not know what kind of storage devices will turn up tomorrow.